What's up, everybody? In this video, we're going to learn how to write an analog output from the Arduino. To do this, we will control the brightness of an LED. You might be thinking to yourself, isn't the Arduino digital? How can we make an analog signal on a digital device? The Arduino can simulate an analog value using something called pulse width modulation, or PWM. When we build an analog output on the Arduino, our circuits can be the same as digital outputs. However, we need to connect the component to a special pin on the Arduino. You will notice that some pins have a tilde before the number. These pins can simulate an analog output using pulse width modulation. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to LED-analog write. The circuit for an analog LED output is the same as a digital LED output. Select an LED from the components and add it to the breadboard. Click on a resistor, rotate it using the R key, and place it on the breadboard. Change the resistance to 220 ohms. Add a black wire that connects the cathode of the LED to ground. To send an analog output to the LED, we need to ensure that our LED is connected to a pin with a tilde. Add a yellow wire from the resistor to pin 3 on the Arduino. You could also use pins 5, 6, 9, 10, or 11. Now, we will add code to write an analog output. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is LED-analog write, and the description is a sketch where we will write an analog output to an LED. Declare the variables for the LED. Create a variable to hold the value of the Arduino pin connected to the button. Type int LED pin equals 3, semicolon. In the setup function of our code, we need to tell the Arduino that the LED will be an output. Underneath the serial statements, add pin mode, open bracket, LED pin, comma, output, close bracket, semicolon. You will notice that this is the same if your circuit is digital or analog. Next in our loop function, we will write an analog value to the LED. When we send a digital output, we use the digital write function. To send an analog write, we will use the analog write function. Like the digital write function, analog write accepts two parameters, the pin and a value. Type analog write, open bracket, LED pin, comma, 255, close bracket, semicolon. The value for an analog output on the Arduino is between 0 for always off and 255 for always on. You can write any value in between 0 and 255. Click Start Simulation and you should see the LED light up. Stop the simulation and try different values between 0 and 255 for the output. You should see the brightness of the LED change. This can be annoying to try and test the brightness of the LED. Let's have the Arduino generate a random number between 0 and 255 to change the brightness of the LED each time it loops through the function. Generating random numbers in programming is useful for creating applications where we want to produce an unpredictable result. In this case, I do not want to have to stop and start the simulator to change the analog write values to a number between 0 and 255. Right before the analog write function, add int rand number equals random open bracket 0, 256 close bracket semicolon. We're doing two things here. First, we are declaring a variable called rand number. Second, we are using the random function. The random function accepts two parameters, a minimum value and a maximum value. It should be noted that the maximum value is your desired value plus 1. Previously, when we declared our variables, it was outside of our functions. Any variable declared outside of any function are known as global variables. Global variables can be accessed by any function. Since we created rand_number inside of a function, it is what is known as a local variable. Local variables are declared inside of a function. Local variables are only understood and used inside of the scope of their function. If we try and access a local variable outside of their scope, we will get an error with our program. Use the rand_number variable for the brightness value in the analog write function. Add serial.println open bracket rand_number close bracket semicolon so we can view the random numbers in the serial monitor. Change the delay to 500 milliseconds or half a second. Click Start Simulation and you should see the brightness of the LED changing every half a second. At the end of this video, you should have a better understanding of how to write an analog output using the Arduino, random numbers, and global and local variables.